Explain the working principle of circuit breaker. Circuit breaker is one which makes or breaks the circuit. It has two contacts, namely fixed contact and moving contact. Under normal condition, the moving contact come in contact with the fixed contact, thereby forming the close contact for the flow of current. During abnormal and faulty conditions, or when current exceeds the rated value, an arc is produced between the fixed and moving contacts, and thereby it forms the open circuit. Arc is extinguished by the arc quenching media like air, oil and vacuum, and etc. What happens if I connected a capacitor to a generator load? Connecting a capacitor across a generator always improves power factor, but it will help depend upon the engine capacity of the alternator. Otherwise, the alternator will be overloaded due to the extra watts consumed due to the improvement on power factor. Secondly, don't connect a capacitor across an alternator while it is picking up or without any load. What is the difference between isolator and circuit breaker? Isolator is an off-load device which is used for isolating the downstream circuits from upstream circuit for the reason of any maintenance on the downstream circuit. It is manually operated and does not contain any solenoid unlike circuit breaker. It should not be operated while it is having a load. First, the load on it must be made zero and then it can safely operate. Its specification only related current is given, but the circuit breaker is on-load automatic device used for breaking the circuit in case of abnormal conditions like short circuit, overload, and extra. It is having three specifications. The first is rated current, the second is short circuit breaking capacity, and the third is instantaneous tripping current. What is the difference between MCB and MCCB? Where it can be used? MCB is a miniature circuit breaker which is thermal operated and used for a short circuit protection in a small current rating circuits. MCCB, more dedicated circuit breaker, and is thermal operated for overload current and magnetic operation for an instant trip in a short circuit condition. Under overload and underload frequency may be inbuilt. Normally it is used where no current is more than 100 ampere. What are transformer losses? Transformer losses have two sources, copper loss and magnetic loss. Copper losses are caused by the resistance of the wire, that means I square R, and magnetic losses are caused by eddy current and hysteresis in the core. Copper losses is constant after the coil has been wound and therefore measurable loss. Hysteresis loss is constant for a particle voltage and current. Eddy current loss, however, is different for each frequency and passed through the transformer. What are the advantages of a star-delta starter with induction motor? First, the main advantage of using the star-delta starter is reduction of current during the starting of the motor. Starting current is reduced to 3 to 4 times of the current of the direct online starting system. Second, as the starting current is reduced, the voltage drops during the starting of the motor in the system are reduced. What is exciter and how does it work? There are two types of exciters, a static exciter and a rotary exciter. Purpose of the exciter is to supply the excitation DC voltage to the fixed poles of the generator. Rotary exciter is an additional small generator mounted on the shaft of the main generator. It is a DC generator and it will supply DC to the rotary poles through the strip rings and brush, or the conventional alternator. If it is an AC exciter, output of the AC exciter is rectified by rotating diodes and supply DC to the main field poles. AC exciter is an AC generator whose field windings are stationary and armature rotates. Initial voltage is built up by residual magnetism. It gives a starting torque to the generator. What happens when power factor is leading in distribution of power? If there is a high power factor, that means if the power factor is close to 1, the first loss in the form of it will be reduced. The second, cable becomes less bulky and easy to carry and very cheap to afford. And the third one, it also reduces overheating of transformers. Explain the process of commutation in DC machine. Explain what are interpoles and why they are required in a DC machine. Commutation. It is a phenomenon when an armature coil moves under the influence of one pole pair. It carries constant current in one direction. As the coil moves in the influence of the next pole pair, the current in it must reverse. This reversal of current in a coil is called commutation. Several coils undergo commutation simultaneously. The reversal of current is opposed by the static coil EMF and therefore must be added in some fashion for a smooth current reversal, which otherwise would result in sparking at the brush. The aiming of EMF is dynamically induced into the coil undergoing commutation by means of home poles or interpoles, which are series excited by the armature current. They are located in the interpolar region of the main poles and therefore influence the armature coils only when they undergo commutation. What is the working principle of the operation of single-phase transformer? Working principle of operation of a single-phase transformer can be explained as an AC supply passing through the primary winding. A current will start flowing in the primary winding. As a result, the flux is set. This flux is linked with the primary and secondary windings. Hence, voltage is induced in both the windings. Now, when the load is connected to the secondary winding or to the secondary side, the current will start flowing in the load in the secondary winding, resulting in the flow of additional current in the secondary winding. Hence, according to Faraday's law of electromagnetic induction, an EMF will be induced in both the windings. The voltage induced in the primary winding is due to its self-inductance and known as self-induced EMF, and according to the Lenz's law, it opposes the cause. That means supply voltage, hence called a back EMF. The voltage induced in the secondary is known as mutually induced voltage. Hence, transformer works on the principle of electromagnetic induction.